let me put this.
So oh, we good. Are we good? That one's right. I saw it.
Yes. And then, okay, so this is the one that I was struggling with.
Right. So it's another tree diagram, right?
Right.
And in this case, you have without replacement. And that's going to change the world a little bit. And because we're going to take, is it 2 students? Yes, we are. So let's see. I'm just going to write down the key numbers, then I can switch over. There are 20 children and only 4 are left-handed, which means that 16 then are right-handed. Which is kind of obvious. You have to be one or the other. Right. Okay. And they've got a whole load of guys called A, B. I guess I should write them down so we get the letters right. A, B, and that's going to be left-handed and right-handed. And that's your first person you choose. And then it's 3. I'm just basically copying the blank version of this tree diagram right now. So left-handed, right-handed, and then E, H, that's going to be left-handed and right-handed. And then they finish with, well, it's the second person. And then they finish with a thing that they call the final probability. And that's basically the numbers that are, in this case, probably fractions. Let's check, what do they want? Yeah, they want fractions.
Mm-hmm.
Okay, so let's put those letters in. So the last letters are K, M, N, and W, right? So essentially, we're going to fill that entire list of letters from A to W. In other words, we're going to fill the missing fractions that belong in this tree diagram. Okay.
So the difference between question 4 and then this one, that third question, is it just what you were saying without replacement? Is that
Yeah.
Okay.
That's the key difference. Apart from that, it'll look very, very similar. So for no particular reason except I want some colors, I'm going to be putting the answers as red. So that's the only difference. Now, what do we know about the first person we choose? Well, they come from this world. And this world has 20 children on them, and 4 are left-handed. So the probability that you pick a left-handed child is 4 out of 20. Now, I know that simplifies down to 1/5, but I'm leaving it as 4 out of 20 because it kind of makes it a little bit more obvious where I'm getting the numbers from, right? 4 left-handed out of 20. Right, so if you imagine a classroom, there are 20 kids and you say, Jimmy, come here. Oh, you're left-handed. That would only happen 4 out of 20 times, right? 4/20. So what would be the right-handed probability of the first person you pick? Just randomly pick a kid. What would be the probability they were right-handed?
It would be 16 of 20, right?
Correct. And that looks just like what we did last time, right? You know, the numbers are different. You know, but it's the same idea.
Right.
Now things get messy. Let's look at this probability here, the one they're calling C. What you know has happened is that the first child already committed was left-handed. Now what that means is I've now only got 19 kids to pick from. And of those 19 kids, only 3 of them are now left-handed. So the probability of C is 3 kids out of 19.
Okay.
That's the without replacement bit kicking in. This here means we know something. You picked a kid and he's left-handed. So when you decide who's the second child going to be, the probability of them being left or right-handed is now not 4/20 and 16/20. You see it's now changed to 3/19. What would be the second one for a right-handed kid then? What would the fraction be for this kid? The second kid being right-handed.
Are we pulling from the 4/20 or are we pulling from the 16/20?
We are pulling from 19, 3 left,
already taken one kid. So would it go down to 18?
No, this one is still part of this world. So it's still 19, but it's 16 out of 19.
Okay.
So try and ignore what's happening here and say, okay, you pick a kid, 4 out of 20. Okay. If I choose a left-handed kid, you see the world for the second kid is now a different combination than it was when it was the first kid.
Let me move my, I can't see. Okay, there we go.
Move
Okay.
this a little bit further that way. Right.
You're fine. Our pictures were just over those numbers up top. So
Okay, are we good with the 16, right?
Yeah.
Now, the world's going to change again. The kid I picked was actually right-handed. Oh, well, if it's right-handed, there are 19 kids. 4 of them are still left-handed, right? But 15 of them would be right-handed. You see how the world has now changed in this situation? The first child was right-handed. 19 kids left, 4 left, still 4 left-handed, but now only 15 right-handed. So the probability that you get a left-handed kid is 4 out of 19, and the chances that you get a right-handed kid is 15 out of 19. So do you see that these two are not the same fraction as these two? They all share 19 on the bottom because there's 19 kids to pick from. But you can see in this world up here, it was that combination. And in this one down here, the bottom one, it was this combination. And that's the trick to making this work.
okay. I see what you're doing, and I
Right.
like am comprehending it. It's just gonna
Right.
take me a minute to kind of like get my brain to. It's just tricky, I think.
Yeah, it is. You got to think, essentially what we're doing here is we're doing conditional probabilities. And for instance, see that 4/19th, you could say that was, what's the probability of picking a left-handed child, given that the first child was right-handed? And that answer would have been 4/19. So it's like, you know something's happened, how has that changed the probability?
Okay.
Now, if it was with replacement, imagine a different story where after you picked a kid, he went back into the class, so you could end up picking him again if you were lucky, I guess. Wouldn't the fraction be 14/20, 16/20? And
Yeah.
then it'd still be 14/20, 16/20. It'd still be 14/20, 16/20. Do you see how with replacement, once you know this pair, you basically just duplicate it for as many people as you choose?
Yeah.
Right. Okay. So to finish with, we need to get, because that's the answer to A, B, C, D, E, and H. All we need to do now is get K, M, N, and W. How do you get, for instance, K? What would calculation be to find K?
I have no idea.
Okay, if you want to get a destination point, you multiply the pathway that gets you to there.
I was
So
about
to
to
get,
why, but my thinking was not what you just said.
okay, I don't know, have what I just said then make sense then? Do you say,
Yeah.
I remember, that's what we did with the
It was
decimal.
a guess for me, but then once you explained it, it kind of clicked in.
Okay, so if you multiply this guy by this guy, which is probably, I could do it in the calculator if I clear this thing often enough. You go, what's that going to be? Well, it's a little bit harder with these ones. I like to put brackets around things when they get complicated. So there's my 4/20ths. The reason I'm putting a bracket around it is just to make sure that the calculator does it in the order I want it. Right? Now, if I do that, I get the horrible decimal, but then I can do math button, choice number 1, and make it a fraction. 3/95. Now, if I do the next one, it's 4/20ths and 16/19ths. Ugh, okay. 4/20ths times 16/19ths. And then I can do the math number 1 again, and that gets me 16/95. And this one times that one. None of these are going to be nice, are they? Okay. 16 divided by 20 times 4 divided by 19. And the math button number 1 again. And that ends up being, 16/95. And I should be able to figure out what the last one is. 16 and 16 is 32, 33, 34, 35, right? That adds up to 35, which means there should be 60/95 left. Now, I know that's not quite the answer, but I know it's going to be simplified as that answer. So bracket 16 divided by 20 times bracket 15 divided by 19. You got this guy. I'll go math number 1. And the answer I get is 12/19. And you might think, oh, darn it, it's not right. 16/95. 16/95, right? That answer. Hit enter. Go math. Choice number 1. And the answer is 12/19. So it worked. So I checked it by figuring out that these have to add up to 1. And then I actually did the calculation and it matched, which is a really good sign that we did it correctly.
Makes sense.